In this video, we'll look at some of the things that can go wrong in loops. It falls into two categories: things that the compiler can find, compile time errors, and then uh, errors that the compiler cannot find but turn up at execution. There's more moving parts here, so more things to look for and pay attention to. So when you start using loops, I'd recommend adding an output statement to the very end of main and putting the body of your program in here so you can confirm that your program reaches a normal termination. So compile this, debugging for loops. Debugging for loops, program ends. Okay, so we're going to write a loop in here. And you can call the loop variable anything that makes sense to you. For example, loop var equals 1 to count from 1 to 10. Do something like this. Uh-oh. All right. So one thing that can go wrong, right, is that if you use a different name for the loop variable, you have to stick with it all the way through. All right, so if I want my loop variable to be named loop var, I have to use loop var in the condition, and I have to update loop var in the expression. Right, and then if I'm going to do something with the variable in the body of the loop, I have to use that. Okay, so normal sort of thing. Going to 9. All right. You want to go from, remember, if you want to start at 1, all right, you may want to use an less than or equal to count up to exactly reach your bound. This depends on the exact problem. Another thing that can go wrong, of course, is just typical like misspelling, right? That sort of thing. You can maybe get the operators wrong. All right, so there's a couple of new operators here. We have a plus plus and then the plus equals operator, which has a right-hand side. Okay, sometimes it's either way is fine. All right, but you don't want to get them. Sometimes people get them messed up. Unexpected type. All right, so it doesn't always, the error message doesn't always say exactly what's wrong, but it's generally around the line it's pointing to. So you got to get these operators correct. All right, but if you're going by 1, most programmers will write that, and we'll use the plus equals operator if it's a value different from 1. Count by 2s. Start at 1, and notice that, right, we're not going to exactly get to 10 because we're counting by 2s. All right, so this depends on the logic of the problem you're trying to solve. Another thing that can go wrong is leaving or using the wrong symbol here to separate the parts. For example, commas instead of semicolons. And this is a pretty good error message. Semicolon expected. Right. Illegal start, semicolon expected. So that kind of reminds you that the 3 parts of the loop header, right, the initialization, right, the condition, and the update are separated by semicolons. Even if your loop compiles, and the program runs, it may not do the right thing. All right, so let's take, for example, a loop, right, that has to go up by 1. All right, and we'll just count by 1s for this example. All right, whether or not you start at 0 has an impact on it. So you can have off by 1 error. So if I'm trying to count from 1 to 10, right, this is starting at 0. I want to count likewise. This stops too soon. So you have to consider your start and stop values when you're setting the initial value and the condition. The loop does not have a semicolon following the header. This is a subtle error because in this case, the compiler gives you an error that says it cannot find the symbol, but it's right there. It's the loop variable. Okay, so what the semicolon does effectively is cut off. It separates the body of the loop from the header, so the whole loop becomes that, and this just becomes a separate scope. The loop variable doesn't exist in this scope, so that's what the error means. So in general, a block when a header has a block of code and braces following it, it will not have a semicolon. Suppose I initialize the loop variable here. It's possible to do this. You don't have to create the loop variable in the initial condition. You could have, here I could have created it earlier and just given it a value in the initial condition. That's an alternative. So you see this does the expected thing. But now, watch what happens if I have the semicolon here. It compiled. Okay, so in this case, it compiled because the variable is not part of the loop header. It's just it's independent of that. So here it's recognized, even though the loop body is still cut off from the header. But watch what happens when it runs. Loop var is 11, but I only see it once. I only see it once. Okay, so here's what happened. Right, when you have a semicolon, the end of a loop header, the loop will execute, and you see what in fact what happened. Loop var started. It started at 0, then it got changed to 1, and as long as it was less than or equal to 10, there was no body to execute. There was no loop body to execute, so it just went straight to the update and then back to the condition. So it incremented and checked to see if it was less than 10, incremented, checked to see if it was less than 10, until it wasn't less than or equal to 10 anymore, which meant it was 11. Right, and that explains the output that we saw. So this is a logic error that was not found by the compiler. The loop didn't caused by a semicolon, when really what if your intent is to see the output from within the loop, then like this. And notice you do not see the value of loop var after the loop ends, because this statement is only repeated as long as this is true. Once the loop condition becomes false, the body of the loop isn't going to happen anymore. Another thing that can happen, and this frequently happens when you're trying to starting to count loops down, is loop won't execute at all. Suppose I want to count down from 10 to 0. Okay, well, it compiled, but there's no loop at all. I see the intro message, debugging for loops, and then program ends. Program ends. So this is an example of why a message at the end of your program can be useful, because it very plainly shows that my loop got skipped entirely. Okay, well, why did the loop get skipped entirely? Because loop var got set to 10 as the initial condition, but then the condition that it checked was loop var less than or equal to 0. Well, 10 is not less than or equal to 0. 10 is positive. It would have to be negative or 0 for this to be true. So it was false. So the loop condition can be initially false. So this initial value made the condition false the first time it was looked at. So the whole loop is skipped. So we never do this at all. We never do this at all. And you just skip it. It's like an if statement that's false. So this is a loop that never executes at all. That can be the problem. The issue here is that I need to, if I'm going to start high and end low, I want to see if my loop variable is greater than the end. Okay, well, does that fix it? Compiles. Oops. No, it doesn't. Okay, here we have a different problem. We have the opposite problem. Instead of not executing at all, the loop never stops. Okay, so this is a runaway loop or an infinite loop. And you can stop this by holding down the control key and typing a C. And it may take a second or two for the control C to interrupt the program. It gets way ahead of itself. Another thing you can do if that doesn't work or if it's taking too long, you can just close the terminal and then just start another one. So I'm not going to run that again because there's an infinite loop in it. The problem, let's see if I can do it real quick. Okay, Control C. There it goes. Okay, so if you press it fast enough, right, it catches it. You can kind of see what's going on here. If I scroll backwards, right, there's a lot of output really fast. The loop var very quickly got into the multiples of thousands. 35,424, 35,425. It's going up. It's going up. Right, so I started at 10, and I said, well, as long as the loop variable is greater than 0, great. Print the loop variable, and then increase it again. Well, if it started at 10, and you're testing it to see if it's greater than or equal to 0, if you increase it, it's always going to be greater. You're not moving in the right direction. Okay, so this is infinite because when you're counting down, the update has to reflect that. All right, so let's try that again. And there you go. All right, so those are just a few of the things that can go wrong with loops that you want to be aware of when you're using them to solve problems.